Today on this lesson, we are going to see some exercises on further pure mathematics exam papers. The first question is a question on finding equations of straight lines, and the line is 2x plus y equals 3. The line M is parallel to the line L and passes through the point 1 minus 6, and we want to find the equation of the line M, the line that is parallel to the other line L. We start by writing the equation of the straight line. The equation of a straight line is y minus y1 is equal to m times x minus x1. So we need to find the gradient and a point. Because this line is parallel to the first line, the line L, the gradient of the L is the same as the gradient of the other line M. The two lines are parallel. And therefore they have the same gradient. And now rearranging the 2x plus y equals 3, we found the gradient as -2, and therefore the gradient of the M is -2. And to find the equation of a straight line, I need to know the gradient and a point. So the point is -1, -6. So I follow the equation. Y minus y1 is m times x minus x1. I put the gradient and the point, and I found the equation. The second line is perpendicular to the line L and passes through -5, 4. In this case, because they are perpendicular, we need to remember the perpendicular condition, m1 times the m2 equals -1. Because the two lines are perpendicular, then we can use this equation to find the gradient of the other line. And since the gradient of the L is -2, the negative reciprocal is half. And since we know a point and the gradient, we can use exactly the same equation we used before. The y minus y1 equals m times x minus x1, and the point I'm going to use is the point here, the -5, 4, and the gradient of the line N. And using the gradient and the point, I can rearrange it and find the equation, which is half x plus 13 over 2. To find the point of intersection between the line N and the horizontal axis, so all we need to do, remember that the horizontal axis, the y is a 0. So we use this equation we found, and we use the y equals a 0 and find the x coordinate. So the x is -13, so the point of intersection between the x axis is -13, 0. This is the x-intercept. The second question I have on the screen is algebraic fractions, simplifying algebraic fractions, especially combining them into one single fraction. And here I have a subtraction of two fractions. I have 3x over x minus 3 times x plus 6 minus 2 over x plus 6. To subtract fractions, we need to make sure both of the fractions have the same denominator. And if you see the second fraction, then the denominator is not the same with the first fraction. So what we are going to do is to change the second fraction into a denominator x minus 3 times x plus 6. And to do this, we use the method of equivalent fractions, and we times both by x minus 3. So in this case, this fraction is 2 bracket x minus 3 over x plus 6 bracket x minus 3. And you see now I have the same denominator, and now I can combine the two fractions and into a single fraction, and after multiplying the two brackets, as you see on the screen, I have x plus 6 over x minus 3 times x plus 6. The x plus 6 cancel out, and what is left is this single fraction, 1 over x minus 3. The other exercise I have on this screen is changing the subject of a formula. This formula starts with the x and take the square root of a fraction y plus 1 over y minus 2. So we're going to change the subject of the formula from x to y. And to change the subject, I need to find a way, so using the inverse operations to cancel the operations I have and make the y the subject. Because I have the square root, as you see on the screen, I have the square root. I need to square both sides, and I start squaring both of the sides as x squared equals y plus 1 over y minus 2. And you see I have cancelled the square root. And I'm going to do step by step the inverse operations until I have y the subject. The next thing I did here is to cross multiply this equation to remove the fraction. By cross multiplication, we have x squared times y minus 2 is equal to the y plus 1. And since I have two y's, one on the right hand side and one on the left hand side, I need to expand the bracket on the left hand side and bring all the y's into one side. So I subtracted the y on both sides to bring all the y's into the left hand side. And after that, I multiply the brackets and then factorize, because on the left hand side I have two y's, and you see here I have y. I take the y out of the bracket, then I open the bracket. X squared minus 1 is equal to 1 plus 2x squared. Dividing both sides by x squared minus 1 give you the y. I make the y the subject, and this is the answer. So the answer is this one. So the y is 1 plus 2x squared over x squared minus 1. So I did the inverse operations on both sides until I have y on one subject only. And the other exercise I have on the screen is trigonometry, and using this right angle triangle with sides 1 and 1, angle 45, to show that the sine 45 is 1 over root 2. To show, we may start with the definition of the sine function, and the definition of the sine function is the opposite over, so the sine 45 is the opposite side over hypotenuse, but as I don't have the hypotenuse, I need to find it using Pythagoras theorem. So I apply the Pythagoras theorem, and then I found x as square root of 2. And now I'm ready to apply this formula for the sine. So the opposite of 45 is 1, and the hypotenuse is square root of 2. So I have proved this trigonometric ratio. So it's 1 over root 2. This part B on this exercise gives you a different triangle with sides square root of 3, square root of 6, an angle 45, an angle theta, and they ask you to find the value of theta. This is not a right angle triangle, and if it is a not right angle triangle, the ratios to use is the sine rule, or you may use the cosine rule. In this case, the sine rule, we start with the sine rule because I have two angles, one is missing angle, and two sides. So I use the sine rule, and I have sine 45 over root 6 is equal to the sine theta over root 3. And all I need to do is to solve this equation by cross multiplication. And you see I make sine theta the subject, and after making this I found the inverse of the fraction, and I found the angle theta, and the angle theta is 13 degrees. On the exercise 12, here I have a circle with equation x minus 7 bracket square plus y minus 4 square is equal to a 9. Now the equation of the circle is, if I have the equation of the circle, I can find the center. The center of the circle are the values of x and y that make the bracket 0. And so the center is 7,4. The center is 7,4 and the radius is the square root of 9. So this gives you a 3. And since I have this information now, I have this center, I have the radius, they ask you to show that the A and B is 2 square root of 5. So the length A and B is 2 square root of 5. We also know that the line y is 6 intersects the circle at A, A and B. If you see here I have a triangle that is an isosceles triangle, and you may also draw the height of this triangle AC and B and find the AM, because if the AM is root 5, the total, this is a midpoint, so the total is 2 root 5. So if I use the triangle here and find the AM, this is a right angle triangle, and then I can find also the AM. So let's see here how I found that is 2. The height is 2 here because I know the radius is 3, and if I extend the line here, this is the height, this is the radius, is 3 minus 1. I know the radius is 3, and the center, the vertical axis is 4. So if you see the coordinates of the point is 7,4. So the distance between C and D, the distance between C and D is 3, is the radius. And the distance between C and M is 2. Okay, because I have the coordinates on the 6 here. So I can use the Pythagoras theorem and find the AM, and the AM is root 5. So the A and B is 2 root 5. The next exercise is rearranging fractions to find the x value. And to find the x, you may use the inverse operations until you find the x in one side. So you times both sides by root 3, and you see how here I have an equation root x times root 8 is equal to 4 root 15, dividing by root 8, and this gives you the root x, which is 2 root 15 over 2. I square both sides, and then I have the value of the x. By squaring, I have 2 times 15 is 30 degrees, 30 centimeters. The next topic is a factor theorem, and the x minus 5 is a factor of the cubic function x to the power of 3 minus 6x squared plus 8x minus 20. And if this is a factor, the factor theorem says that the f5 must be equal to 0, because if the a is a solution, if the x minus a is a solution, the fa is 0. So by using this equation, f bracket 5 is equal to 0, it's possible to find the a as well, and you can find it, that is 9. Number 15 is give you a graph of a parabola passing from 2 points P and Q, and the graph is x minus 2 times x minus 3. The curve intersects the horizontal axis at the points P and the Q, and show that the tangents at the point P and the Q are perpendicular. So to show that they are perpendicular, we need to find the gradients. And if they match the condition m1 times m2 is -1, then it has to be true. Okay, they are perpendicular. So one way to do this is to find basically the gradient of the function at the point P and the Q. One way to find the gradient is by the derivatives and finding the differentiation, by differentiation. So if you apply differentiation, you see I expanded the brackets, x minus 2 times x minus 3, and I have a quadratic. And the gradient is the same as the derivative. So if I found the derivative of the quadratic at the 2 points, P and Q, I can also find the gradient of the tangents. And if they meet this equation, then it has to be perpendicular. So I found the derivative, I used the point 2 and 3, and I found that both are minus, one is -1 and the other is 1, which proves that the equation is true. So it must be perpendicular. And the last question I have is to show that this expression is always a multiple of 4. One way to do this is to expand the brackets and make it divisible by 4. So if it's always a multiple of 4, so you see that the numbers, the n plus 2 and the n plus 1 are consecutive numbers on the number line. And because they are consecutive numbers, so if it's both have to be even, because if one is odd and I subtract 1, then I have an even number. So it is both even, and then you can see here I expanded the brackets, I expanded both of the brackets, and I came into an expression 4k squared plus 4k, so it is plus 2k squared, and then I prove that this can be divided by 4, so it is a multiple of 4. You see here I factorize to show, because I make it a quadratic, and then I factorize, and the n plus 2 and the n plus 1 are consecutive numbers, which means one is even, and I times an even by 2. An even number is already can be times by 2. 2 times 2 is 4, so it has to be a multiple of 4, because I factorize the 2 out of the brackets, and one of the factors is an even number. Even number times 2 give you a multiple of 4. Thank you for watching. If you like the lesson, you can subscribe to see more lessons like this.